All right, so we're going to solve some systems of equations using substitution. Make sure you are using substitution, not any of the other methods. Okay, and certainly not guess and check. All right, so our first one's a word problem. Tickets to a show cost $10 in advance and $15 at the door. So those sound important. 10 in advance, 15 at the door. If 120 tickets are sold, so that's total tickets. That's both advanced and at the door. And they make a total of $1,390. How many of the tickets were bought in advance? Okay, so it only asks us for one of the types of tickets here, but we do have two unknowns, and that's why we're going to need a system of equations. All right, if you have two unknowns, you have to be able to write two equations in order to solve it. So our first step is to identify what are our unknowns. We need to write two let statements, an x and a y. Okay, well, if we know one of the variables is the number of advance tickets, that probably leads us to figure out that our other unknown, our other variable, needs to represent the number of door tickets, tickets sold at the door. Now, as you read through that information, and feel free to read it over and over as many times as you need to till it all makes sense, but you're going to have two equations based on two types of information they're giving you. One of the bits of information is about, one equation will be about money. They give us $10 in advance, 15 at the door, and the total amount of money. But the other equation then, this 120 tickets sold, that has nothing to do with money. That's just about total numbers. So one equation will be about money and one equation about number of tickets. Okay, keep that in mind. You don't want to reuse any of these numbers. You don't try to force the 10 and the 15 to be in both equations. Okay, so the equation about money, if it's $10 for every advance ticket and I'm selling X of those, so 10 times X, I'm going to also, in addition, so sell some door tickets. They're $15 each, and I sell Y of those. Now, both of these terms, the 10X and the 15Y, are about money, the money made from selling those tickets. So it's not going to equal the 120, but the 1,390, because that's the one that's about money. The other equation, which is going to be about number of tickets, don't get confused and frightened when you don't think you have enough numbers. The variables themselves stand for number of tickets. You don't have to have coefficients in front of them. So the 120 should be our answer when we add together all the advance tickets plus all the tickets sold at the door. So X plus Y is equal to 120. And that's the equation that is just about number of tickets. Okay, so our first step in solving by substitution is to choose one variable. You usually have four to choose from, an X, a Y, another X, another Y. Choose one of those four, and it's completely up to you, but pick one and solve for it. I mean, isolate it. So just because it's staring at me right here at the bottom, I'm going to go ahead and work right from here and say, I'm going to solve for this Y. All right? It's always simpler if you have a variable that has a coefficient of 1 or you don't see a coefficient. It's always simpler to solve for that one. Okay? So to get this Y alone, I need to subtract X on both sides so that Y is equal to, now you can either write that as negative X plus 120 if you're thinking slope-intercept form, or 120 minus X, it doesn't matter. Now that is the step that I have suggested that where you box it, okay? So I solve for Y, I put it in a box. Now why did I do that? Here's where the name of the method comes in. We are going to substitute this box into the other equation. Now we can't put it back in the equation we already used just because it looks simpler, because everything just cancels out and we'll think, oh, wow, that's all real numbers work. We have to put it in the other equation. since this box represents y, that means I'm going to go to the other equation and I'm going to remove this y variable and replace it with this box. Okay? Because what I found out here in pink is y and the box are the same thing. They're equivalent. So wherever there's a y, I can replace it with this box. All right? So that will give me 10x plus 15 times the box equal to 1390. All right. And at first glance, that looks like you just made your problem harder. Why did I do that? Well, yes, it is a longer equation, but if you look more carefully at it now, it is now just a linear equation in one variable. There are no more y's, or sometimes there are no more x's, but you should now be down to only one variable, or else you've made a mistake already, okay? If you get to this step and you have more than one different variable, you need to check your work, okay? So solving this, I need to first distribute 15 times 120 and 15 times negative x. So 10x plus 15 times 120 is 1800 minus 15x is equal to 1390. Now I have some like terms. 10x minus 15x is negative 5x plus 1800 equals 1390. Subtract the 1800 on both sides. So negative 5x is equal to negative 410. And divide both sides by negative 5, and a negative divided by a negative will result in positive. This would be 82. Okay, so what does that mean? Well, now it's important to remember my let statements and go, oh, well, x, right from the beginning, we said that stood for number of advanced tickets. So that's 82. Now, I realized that in this problem, that's all they asked me for, is how many tickets were bought in advance. So really, I've fully answered the question that was posed. However, just to be certain that it all makes sense and that this works out with the other amount of tickets also, to solve for y, I substitute that x back in the box. So my y value would be 120 minus 82. So 120 minus 82 is 38. So that means I have 38 door tickets. In order for this to be the correct answer, those two numbers, that x and y value, they have to work in both equations. So you could plug those into both equations, substitute them in, and see if they give you the right values. You would always know when you turn this in whether or not you're correct. Okay? Now, again, this only asks me how many of the tickets were bought in advance. So the answer to that question is 82 tickets were bought in advance. Okay, starting at number 2, we no longer have scenarios attached. They are just sets of equations. Okay, so again, the first step is to choose from my 4 variables that I'm looking at, choose to isolate one of those. Well, this one, that step is almost cut out of the problem because 2 of the variables are already isolated. So I will think of myself, I'll tell myself, I solved for this y up here in the first equation. So I'm going to box the 2x plus 1. Okay. Now, what do we do with the box? We substitute it into the other equation. Well, if y is equal to the box, then I'll replace this y with everything in the box. That results in 2x plus 1 equal to negative x plus 4. Let's solve that linear equation. We will add x to both sides. So 3x plus 1 is equal to 4. Subtract 1 on both sides, so 3x is equal to 3. Divide both sides by 3. Your x value is 1. Now, you have not solved the system here. You have solved for one of the variables. Solution to a system of equations is always an x and a y. It's a point. So this is one of my 2 numbers I need to find the other one, we substitute that back in the box. So the y value would be 2 times, we just found out x is 1, plus 1. Well, 2 times 1 is 2, plus 1 is 3. So if x is 1 and y is 3, my solution here is the point 1, 3. Again, that has to work in both equations if you were to plug it in to check. Number 3, pick one variable to isolate. Well, again, if one of the variables, one or more of the variables is already isolated, use that to your advantage. I'm going to box the x minus 5 because this y is already alone. Next step, substitute that into the other equation. So I replace the y down here with x minus 5. That gives me 2x plus x minus 5 equals 4. Now I use those parentheses because I was substituting. They're not doing a single thing there though. You can just drop them, ignore them. 2x plus 1x is 3x. Minus 5 equals 4. Add 5 to both sides. So 3x is equal to 9. And divide both sides by 3. Your x value is 3. In order to find y, we plug that x back in the box. So y is equal to 3 minus 5. 3 minus 5 is negative 2. Therefore, my solution is the point 3, negative 2. Number 4. Now we finally get some work to do. None of the 4 variables are isolated yet. I have 2 of them, though, that would be very simple, like one step away from being alone. They are this x in the first equation and this y in the second equation. Either of those would be good choices. You do not, I don't think, want to solve for this y variable in the first equation because it has a negative sign in front of it. That can be nothing but trouble. Okay? So I'm going to choose this first equation, x minus y equals 1, and I'm going to solve for x. So in order to isolate that x, I will add y to both sides, leaving me x equals 1 plus y. And that's the one I box, put it in a box. I did that so I can substitute the box into the other equation. This time, since I solved for x, I'm substituting it in where the x used to be in that equation. So that results in 2 times 1 plus y plus the y that was already sitting there equals negative 7. Okay, we distribute first. 2 times 1 is 2. 2 times y is 2y. Bring down the y that was sitting alone equals negative 7. Like terms here, 2y plus y is 3y. So 2 plus 3y equals negative 7. Subtract 2 on both sides. So we are left 3y equals negative 9. Divide both sides by 3. Y is equal to negative 3. That's half of my solution. To get the other half, I substitute that value back in the box. So my x variable is 1 plus the value I just found, negative 3. 1 plus negative 3 is negative 2. So my solution to this system is the point negative 2, negative 3. And number 5. Once again, we get to do all the steps here because there is no variable that is already isolated. Good choices would be this first x or this second y, since they have coefficients of 1. I am going to use that top equation, x minus 3y equals 10, and I am going to isolate the x. So in order to do that, I need to add 3y to both sides. So that gives me x is equal to 10 plus 3y, or 3y plus 10. And that is what I will box. Okay, I did that so that I can substitute everything in that box into the other equation, the one I haven't used yet. So it goes right there. That new equation is 10 times everything in my box, 10 plus 3y, plus there was already a y here, so plus y equals 13. Start with distributive property. 2 times 10 is 20. 2 times 3y is 6y. Bring down this other y, 1y equals 13. Like terms, 6y plus 1y is 7y, so 20 plus 7y is 13. Subtract the 20 from both sides. 7y equals negative 7. Divide both sides by 7. Our y value is negative 1. Again, that gives us half of our solution. To finish it, we need to substitute that value back in the box. So x will be equal to 10 plus 3 times our negative 1. 4x is 10. 3 times negative 1 is negative 3. And 10 minus 3 is 7. So the solution for number 5 is the point 7, negative 1.